Okay, the recording started just in case. It looks like there's still some people who have not logged in or haven't been able to find us, but we'll give it, so I'll record this just in case they're out for the duration. The goal for this week is to basically get everybody with their computers uh, getting R Studio and Anaconda up on their home computers. So I guess the question is, I know there were a couple of questions that came through by email, one or two this morning that I didn't quite get to. So how'd you make out? All good? Anybody not all good? Well, they must be the people who aren't here. In which case, we're in pretty good shape. I think that's really good. I'm just banging through the list of everybody who's here. So I want to go ahead and share with you, because what we're going to do is everybody should have the availability of the Anaconda Navigator. And so what I'm going to do right now is share my Anaconda Navigator screen with you. If I can move my little toolbar out of the way. I really need another monitor at home so I can see what the heck I'm doing here. You guys can feel free to start your Anaconda Navigators if you want to work along. I will warn you up front that what we're going to do next can actually take a little bit of time on your computer. So, you know, you may not want to do everything simultaneous to me, but what I want to show you is one of the huge advantages of working with Anaconda. And I'm not quite sure, I tried to leave this as pristine an installation as I could. This is actually on my Mac notebook, but the good news is Anaconda Navigator looks exactly the same, has all the same availability, no matter what operating system you're working with. But using Anaconda on a Mac has a couple of big advantages. So, and I'll go ahead and show you those. First of all, the one thing that I do have loaded on mine, and I'm not sure about yours, is notice the first block here, which is the Jupyter Notebook. And we'll actually be starting to use the Jupyter Notebook next week. So that's my plan for Tuesday. And that's why I want to get everybody up and running. One of the problems, and this is a big problem in any kind of data analysis, big data, bioinformatics especially, and certainly systems biology in that regard, is that there's no laboratory notebook. Okay, if you're in chem lab, or if you're in genetics lab, or you're in molecular biology or biochemistry or analytical chemistry, physics, any science, any area of science, you have a laboratory notebook that you write everything you do in. And for those of you who have probably done at least some of this type of work in the past, for example, looking up DNA sequences. Okay, you may be looking for a DNA sequence, you may be looking for a protein sequence, you might be going into the NCBI site. Okay, everybody knows NCBI, National Center for Biotechnology Information. Okay, whether you're using the protein database or the PDB server, which is part of the European Molecular Biology Group, or any of these areas to look up sequence information, everything's done on the web. You're working in a browser. You plug in some stuff, information that you're searching, and you get a result. And then you take that result and you move on. Now, if you find an answer, and then you wait 2 weeks to get a hold of your professor, mentor, whatever, and you hand your results in or you go to discuss it, and the question comes up, well, what did you do? And the answer is, I don't remember. It was 2 weeks ago. How am I supposed to know what I did to find this answer? And the reality is all of these databases are changing at a very, very rapid pace. Okay. The information is being added to, is being corrected. A lot of things are happening. So what we really need for computational work is a kind of science lab notebook so that we can keep track of everything that we do at all times. And I think this is a hard thing for people working with any kind of computation to do because they're used to clicking and moving around databases and going here, going there, highlighting sequences, copy, paste, whatever. And they don't really keep careful track of their work process. Jupyter Notebook is a way to do that. And so we're going to use Jupyter Notebook beginning next week. We're going to use Jupyter Notebook to actually track a couple of small projects. And we're going to start really simple. So don't panic. We're not going to jump right into doing one of these mega three-dimensional graphical analyses, okay? We're going to start really, really simple. And that way you'll get a whole handle on how these programs work and also some of the things that you can do with them. I generally go ahead and launch my Jupyter Notebook when I first start working. Now, I will say that depending on your computer, the launching in Navigator can be slow. And I am going to, what it actually does is it opens, let's see, we should be here. What it actually does when you run your Jupyter Notebook is it actually opens a window in your default browser. See, I'm going to change, there we go. It actually opens and you can see a file list. See on the top, it says Jupyter. And basically what we can do here is we start, I usually use this box on the top right. And notice I have a whole bunch of options up here. I can open a Python notebook. I can actually open R. I can open a text file. I could do all sorts of things. I tend to start out depending upon what we're doing. And so next week, we'll actually open a Python notebook. And I think on Tuesday, we'll do a Python notebook. On Thursday, we'll do an R notebook. So really nothing too exciting. I actually go in, I usually find a spot. Now notice my Mac keeps giving me all sorts of crazy security warnings. And what I can actually do in here is go into my documents folder and I can say, okay, I'm going to start a text file. And now I have access to an editor where I can begin taking notes, and it's just a simple text editor. It's just a simple text editor, and I can begin taking notes. The same thing would be true if I wanted to start a new Python project. Again, notice what happens is it begins by giving me an actual line so I can begin writing Python code. And as you might imagine, because I'm working with the programming language in a notebook, what this allows us to do is actually keep track of all of the commands, allow us to put comment cells in, and I can actually insert all sorts of different things in here. We can do running commentary as well as programming, and then save it and run exactly the same thing later. So this has huge advantages. And especially if later on you want to replicate some work, you can replicate identically what you do just by following along with your Jupyter notebook. Now, in this case, what I'm going to do, I really think I need another monitor here. I have to see what I can do. I'm going to stop the share for a second and I'm going to go back to my Anaconda screen, because what we're actually going to do is we're going to install 2 extra programs, only instead of now using something else, we're going to use Anaconda to do the installation. Now, this is the part that'll take a little bit longer, okay? And, so you may want to start it now, but you'll just have to keep track and listen to it. If not, as soon as we're done, we will move forward. Some people using a Mac and have difficulty running R. And one of the problems they have running R is that depending upon the version of the operating system, the iOS that you're using, the Mac either requires an Xcode system, which is a different graphic interface between the central processing tool and running R, than the later version. So depending on how old your laptop is, this is actually an old MacBook Pro. It's probably about, I'm going to say it's about 5 years old. However, I yanked out the CD DVD player, installed a couple of terabyte solid state hard drives, jacked up the memory, and so now it runs as if it's kind of like a modern MacBook Air and has the most recent Mac operating system running on it. If you find yourself in a job or a graduate school position or a research position, whatever, where you've got to use computers and computation, just get ready to invest in good hardware. And people always ask me what they ought to do, and I recognize that much of this depends on your job. If all you're doing is email, then get the cheapest Chromebook you can possibly find, and life moves on peacefully. If all you're doing is web browsing and email, that's all you need. However, if you're going to do any kind of computation at all, and by the way, this even goes for fairly large Excel spreadsheets or databases, just to give you an idea, I've been working with the Vertebrate Genome Project for the last couple of years, and I currently have I think I've got 4 different duck populations, complete genome sequencing, and I actually have, don't even ask me how I get involved in these things, but I have the narwhal genome along with the beluga whale genome, because my plan is to do some comparisons between the narwhal and beluga whale genomes to try to help explain the phenotypes of some recent F1 hybrids they've discovered in the wild. So it sounds like fun, but those 6 complete genome sequences take up about 300 gigabytes of space on the hard drive. So I tend to put the fastest hard drives I can find, and these days they're all solid state. I try to get as much memory as I possibly can, because especially when you're running software, you want to make sure that you have enough RAM to keep going. Most computers these days limit you to 16 gigabytes of RAM. I will say, however, that one of my laptops over here, I don't even think you could see it. I'll put it in front of me so I think you could see it. This is actually it's a Dell XPS Developer Edition. I really am not a huge fan of Dell computers, but the XPS developer runs Ubuntu Linux. And because if you're running a Linux version, you can actually load 32 gigabytes of RAM. Linux exceeds the limitations of both the Apple operating system and Windows. And so I can take full advantage of 32 gigabytes of RAM on that computer. And so depending on the projects that you're using, if they're substantial enough, you really want the computing power to be able to work with them. If I don't use that computer in order to do it on just my Windows laptop or this Mac laptop, I actually have to log in. I have an account with the Penn State Galaxy supercomputer, and I can log in and do all the work there. So, you know, there are a lot of ways to solve problems, but for my money, the best way to do it is to make sure that you've got up-to-date software and hardware. Arguably, a 5-year-old Mac Pro is not up-to-date hardware, but with the solid-state hard drives and a little extra memory, it does fine for my purposes. And these days, its primary function is so I can do video. Because it's really got a big enough screen compared to my Dell XPS only has a 13-inch screen. This has a 17-inch screen. And for some reason, Macs always seem to do video better than Windows or certainly Linux boxes. So anyway, a little bit of a computational diversion. What I want to do and get you guys to do for Tuesday, so since everybody's got Anaconda running, you want to make sure that your Jupyter Notebook is installed. We will use Jupyter Notebook on Tuesday. But in order to prepare for that, we're going to need 3 other programs in these boxes. The one that we will use probably first is going to be RStudio. Now, you've already loaded RStudio as an independent application. I know, I think Alex was having trouble loading R. I think she must have an older operating system, loading R on her Mac notebook. If that's the case, an easy workaround is to load Anaconda Navigator and then install RStudio right here. Okay, so we are actually going to use, because I want to show you a one side-by-side comparison of using RStudio as an independent application or RStudio through Anaconda, is to go ahead. All you got to do is click install and it'll start working. Okay. Now this is going to just eat up time. All right. So you may as well grab some lunch, get a sandwich. It takes time for it to download and to install. But once it does, this little install box will change to a launch box, just like in the Jupyter Notebook, and you'll be able to run RStudio right from the Anaconda Navigator. I would say it has a brief lag to it compared to running it as an independent application, but really nothing that's going to bother us here. Okay. You can only load one thing at a time. So what I want you to do is load RStudio and then secondarily load Spider. And then finally load this one. It's got a wonderful name, GlueViz. GlueViz. We will not use that next week. But since we're installing applications, not a bad idea to go ahead and get it done. Okay, so RStudio, then Spider, then GlueViz. And if you're wondering what GlueViz does, you could read multidimensional data visualization. Okay, so we're going to use that probably, I'm going to guess, in about 3 weeks. But I figure this is a great time to make sure our computing environments are all set up, ready to roll. The last thing I'm going to mention with regard to Anaconda, and this is really kind of up to you. I do this, just so you know, is if you notice in the upper right-hand corner of the Anaconda Navigator, there's a click box that says sign in to Anaconda Cloud. Okay, and if you go to the sign in, and by the way, you could see RStudio is just about done here. So we've got the launch box for RStudio. So we'll be able to test that. Let's Since I'm here and in the window, let's launch our studio. I'll get back to the other one in just a moment. And of course, there you go. And we immediately get our studio up and running. Really piece of cake. Really a piece of cake. Definitely worthwhile application. Great to do. But getting back to what I wanted to do, so actually I'm going to go ahead since I'm here and begin the installation of Spider. But they do have this click box up here in the upper right, sign in to Anaconda Cloud. Now, Anaconda Cloud is a great spot for you to both store your notebooks, anything you do in Anaconda, whether it's an RStudio program, a Jupyter notebook, etc., you can store for free in the Anaconda Cloud and share it with virtually anyone. You could share it with just classmates. You could make them publicly accessible. You could do whatever. It does require you to register for the account. You go to the Anaconda website. I'm going to switch screens. And basically, it's really no big deal. You're just signing up, use your password, you pick a username, your email, a password, and of course, remind them that you're not a robot, and you're off to the races. And you now have an Anaconda Cloud. And when you go back to your Anaconda Navigator, you can actually sign in. And of course, once you sign in, you now will be connected and all your work will be saved in the cloud. I'm a huge fan of this because you never know what's going to happen. I don't know if you guys have been, I don't know how long you've been using or how much you use computers to do some of your work and some of the things that you do. I got to tell you, the number of times that I've had my computer crash in the middle of a really important analysis, in the midst of an important grant application, in the midst of editing one of my PhD students' dissertations, and lost everything. I got to tell you, it happens, and it happens at the worst possible moment. So if only back in the day we had access to cloud storage where you wouldn't have to worry about any of this, I think that's a really important element of a computation these days. And of course, it does have the advantage that if you wanted to work here, you were working at home on your notebook, you could always go back to campus, forget your computer at home, log on to the Anaconda Cloud and get your information right out of it. And same thing working on Dropbox, just for non-computational non-computational data. So one of my favorite things to do, and I highly encourage you to go ahead and do that. It'll make sure that your data are safe. So that's really where I wanted to get everybody up to speed, make sure we're all ready to go. And any questions, problems loading things?
So we just need those three things: the GlueViz, the RStudios, and Jupyter Notebook.
And Jupyter Notebook, yeah. Yep. And don't forget Spider. Yeah, don't forget Spider.
And can we download that on Apple or no?
Yeah, absolutely. If you're having trouble loading R or RStudio on your Apple notebook, then I would do it through Anaconda.
Okay.
Anaconda, and I'll show you in just a moment. Let me share my website somewhere. Where's web? Chrome. There we go. Anaconda. We don't care about pricing. We just care about the individual edition. And if you go down to the bottom, you find your Install Anaconda. And it automatically gives you the correct applications. I'll go ahead and use the graphical installer. It's just much easier. And then once you get Anaconda loaded, you'll be able to load R right through Anaconda. So that's your best bet.
Okay, thank you.
No problem. All right, so I think we're in pretty good shape. So let's plan on getting ready to go. Next week we'll meet on Tuesday and we'll start doing a little bit of programming and introduce you to a couple of neat things you could do with beginning with Python, and then of course we'll head into R on Thursday.
Okay, do we have anything due on Tuesday, Professor?
Nope. As long as this week is for loading software. So as long as we got software loaded, we can get to work next week. We're good to go.
Professor, I'll just show you an email if I come across with a problem.
Yeah, of course. Just drop me a note.
Okay.
Can you
Thank
show
you.
me how to sign in again through Anaconda?
Okay, all you got to do is use your web browser. Let me get back to it. And you go to anaconda.com. And you can, of course, just click Get Started. And down at the bottom, you've got Download the Installer. And there you go. And depending upon what computer you're using, you just pick whichever one you want. These days, if you have a modern laptop, and as I said, my Mac here is about 5 years old, and it's still 64-bit. So if you've got a 5-year or less old laptop or computer, you should be 64. Windows, if it's 5 years old, it's probably 32-bit. If it's 2 or 3 years old, it's probably 64. But it's hard to tell. Just depends on which one you bought at the time. Okay?
All good.
Sounds good. Have a great weekend, everybody.
All right, take care, Professor.
All right, we'll see you guys.